Everyone, it's Orkan. Welcome to my channel. Today we are going to solve LeetCode 162 find peak element problem. So the problem statement is that we are given an input array and we need to find a peak element and return that peak element. In case if we have multiple peaks, we can return any peak. Another important requirement is that the algorithm must run in log n time complexity. So what's the peak element? Peak element is the element that is more than its neighbors. For example, in the example 1, we have 3, which is the peak element because it's more than 2 and the 1, its neighbors. So we can return it as a peak element. The same way in the example 2, we have 6, which is the peak element because it's more than 5 and more than 4. And we need to return not the element, but we need to return the index of the element and return its index. Okay, so that's the problem. Let's see how we are gonna solve it. Let's take example of 1, 2, 3 and 1, our first example, and let's work on it. So by requirement we need to solve this problem with the log n time complexity, and right away we can say that okay, log n time complexity, we need to use a binary search here to find our peak element. So what we need to do first, we need to mark left and right for the binary search. So our first element would be our left and our last element would be our right. So let's do that in the iteration. In the first iteration, what we do, we are finding a mid element which is equals to 2, and we are comparing the element that comes after it. So basically whatever element comes after the mid, we are comparing. If it's more than our mid element, then we are searching our for our peak on the right side of our array. In this case, yes, the 3 is more than 2, so we are selecting this part and searching for our peak element on the right side. So in the second iteration, so we are moving our left here. So we are moving our left here, and we are searching for our peak element on the right side. In the second iteration, what we do is our mid element is 3, so we are comparing if the element that comes the next element after our mid, if it's more than 3, then we are searching on the second part for our peak. In this case it's not, so we are selecting 3 as our peak element, and we are returning left. We are returning left as a result because it's the index of our peak element. Okay, let's actually take a look at the one more corner case. Let's say that we don't have this example, but we have something like 1, 2, 2, 3, 4, 5, something like this. So in this case, if we are gonna, so in the first iteration, we also move our left to the 3, but as you can see here, our array in the second part is just to keep increasing. So how we can make sure that we are selecting our or on the right side, we are going to find the peak element because it just keep increasing. Well, in that case, we are marking 5 as a peak element because in this case, 5 has only one neighbor, 4, and it's more than its neighbor. And in this case, we are marking as a peak element. So that's how we are going to solve this problem. Yeah, let's put our this algorithm to code. Okay, first thing that we need to do, we need to define our left is equals to 0 because we are starting from the beginning of the array, and we need to define our right which is the last element in the array. So for that, we are taking length -1. Okay, so the next thing that we need to do, we need to, while our left is less than our right, so what we need to do, we need to find first the mid element, let's call it mid, and left plus right minus left divided by 2. So that's how we are finding our mid element, and we are checking if our num's mid element is if our next element that come after the mid, if it's more than our mid element, so mid plus 1, if it's more than our mid element, then we are searching for our pick on the right side of the array. So for that, we need to move our left pointer, so our left is equals to mid plus 1. Okay, so if not, then we are searching for our pick element on the left side of the array. For that, we need to move our right pointer. Right is equals to mid. Okay, that's it. Once we exit this loop, we have our pick. So for that, we need to return our index. So we are returning left. We are returning index, not the element itself, because that's the requirement. That's it. Let's check our code. Okay, it works as expected. So let's go over the code one more time. First, we are defining left and right pointers. Then we are moving our left and right pointers until we find our pick element. For that, we are defining a mid element. And if our mid plus 1, the element that comes after the mid, is more than our mid element, then we are moving searching for the pick element on the right side of the array. For that reason, we are moving left. Otherwise, we are searching for the pick on the left side of the array, and we are moving our right. And at the end, we are returning the index of the element that is the pick. So that's it. Hope you like my content. If you like it, please hit the like button and subscribe my channel. That's it for today. See you next time. Bye.